April 18, 1941, and test pilot Fritz Wendel stands beside a sleek aircraft at the Messerschmitt factory airfield in southern Germany, examining a machine that looks unlike anything else in the sky. The Me-262 prototype gleams in the morning sun, its swept wings and streamlined fuselage suggesting speed even while sitting motionless on the tarmac. But there's something odd about today's test flight. Protruding from the nose of this revolutionary jet aircraft is a conventional piston engine, a Junkers UMO 210 that seems almost comically out of place on a machine designed for the future. Wendel knows why the piston engine is there, knows that the jet engines intended to power this revolutionary fighter aren't ready, won't be ready for months, perhaps years. What he cannot know, what nobody at Messerschmitt or Junkers or in the Reich Air Ministry can possibly understand on this spring morning, is that the engines bolted beneath those wings will remain problematic throughout their existence, that the delays cascading from engine development will push this remarkable aircraft into service so late that it arrives not as a war-winning weapon, but as a desperate last gasp of a dying air force. The story of the Me-262 is not simply about a jet fighter arriving too late. It's about how the most advanced combat aircraft of World War II was crippled by an engine that couldn't survive more than 25 hours of operation, by political interference that diverted production toward roles the aircraft was never meant to fill, and by material shortages so severe that engineers had to redesign critical components multiple times just to keep manufacturing alive. The dream of jet propulsion in Germany begins long before the war, in laboratories where engineers understand that piston engines have reached their practical limits, that propellers lose efficiency as aircraft approach the speed of sound, and that some new form of propulsion will be necessary to push aviation into the future. Hans von Ohain, working with Ernst Heinkel, demonstrates the world's first jet-powered flight in August 1939 with the HE-178, proving that turbojet engines can work, that aircraft can fly without propellers. The Reich Air Ministry, watching this demonstration, recognises the potential for military application and initiates several parallel jet engine development programs. They assign Junkers, one of Germany's premier engine manufacturers, to develop what will become the UMO 004, while BMW works on their own design, the BMW 003. Both companies face challenges that seem insurmountable at times, trying to create engines that can withstand temperatures and stresses never before encountered in aircraft propulsion. Dr. Anselm Franz leads the Junkers team at their Dessau facility, assembling engineers who must solve problems that have no precedent in aviation history. The team decides on an axial flow compressor design, where air flows straight through the engine rather than being deflected outward as in centrifugal designs. This configuration promises greater efficiency and a more compact engine, but it requires precision manufacturing of dozens of compressor blades that must maintain their shape and strength at temperatures approaching 1000 degrees Celsius. The early prototypes reveal problems immediately. Compressor blades vibrate at certain speeds, developing harmonic resonances that tear themselves apart within minutes of operation. Max Bentley, a consulting engineer specializing in turbocharger vibrations, joins the project to solve the blade vibration problem, redesigning the stator configuration and replacing aluminium components with steel ones that can better withstand the stresses. By August 1941, the team achieves their first stable running at meaningful thrust levels, and in December, they complete a 10-hour endurance run, proving the basic design can survive extended operation. The marriage of the Me-262 airframe to the JUMO 004 engine happens slowly, painfully, through 1942 and into 1943. On July 18, 1942, more than a year after Wendel's first piston-powered test flight, the Me-262 finally flies under jet power alone. Fritz Wendel again pilots the aircraft, feeling the strange smooth surge of thrust from the turbojets, noting how different this power delivery feels compared to the reciprocating vibration of piston engines. The flight is successful in demonstrating that jet propulsion can work in a combat aircraft, but it also reveals how far the program has to go before the Me-262 can enter service. The engines are unreliable, prone to flameouts during throttle changes, sensitive to debris ingestion, and, most critically, they wear out with terrifying speed. The early JUMO 004A engines, built without material restrictions, use scarce metals like nickel, cobalt, and molybdenum in quantities that Germany cannot sustain during wartime production. Franz and his team face an impossible challenge. They must redesign the engine to use more common materials while maintaining performance and reliability. The solution involves substituting steel for nickel alloys in many components, developing new heat-resistant steel compositions using manganese, chromium, and other more available elements, and most ingeniously, creating hollow turbine blades that reduce weight while providing internal cooling channels. The hollow blade manufacturing process proves particularly difficult, requiring new welding techniques using silver-manganese alloy solder and specialized fixtures to maintain blade shape during fabrication. Each redesign introduces new problems that must be tested, evaluated, and solved before production can begin. Through 1943, test pilots and ground crews at Messerschmitt report engine failures with depressing regularity. Turbine blades crack from thermal stress, compressor stages seize when foreign objects enter the intake, fuel pumps fail under the harsh operating conditions, and most frustratingly, the engines simply wear out after a handful of flights. Allied intelligence officers reading reports from pilots who've encountered the few operational Me-262s note with satisfaction that the German jets often return to base on one engine, that they sometimes flame out during combat maneuvers, that German mechanics work frantically between sorties to keep the temperamental machines flying. Meanwhile, in late 1943, Adolf Hitler sees the Me-262 for the first time during a demonstration at Insterburg airfield. Surrounding him are senior Luftwaffe officers including Hermann Göring, all watching as the jet fighter performs high-speed passes that leave conventional fighters looking obsolete. Hitler, obsessed with Germany's disadvantage in bomber forces, asks whether the Me-262 can carry bombs. The answer comes back affirmative. The aircraft can theoretically be modified to carry 500 kilograms of bombs, possibly more in future variants. To most of the officers present, this seems like an academic question. The Me-262 is obviously designed as an interceptor, a defensive weapon, to protect Germany from the growing avalanche of Allied bomber raids. But Hitler sees something different. He envisions fast bombers striking invasion beaches, disrupting Allied landings before troops can consolidate their positions, delivering precision attacks against targets that conventional bombers cannot reach. He speaks enthusiastically about these possibilities before leaving the demonstration, assuming his comments will be understood as orders. But development continues primarily on the fighter version, because everyone from Messerschmitt to Luftwaffe Command understands that Germany desperately needs interceptors, not bombers, as American B-17 and B-24s reduce German cities to rubble with raids that involve hundreds of bombers protected by equally numerous escort fighters. General Adolf Galland, commanding the Luftwaffe fighter forces, becomes one of the Me-262's most enthusiastic advocates. After flying a prototype in May 1943, Galland understands immediately what this aircraft means for Germany's defence. With a speed advantage of more than 100 miles per hour over the fastest Allied fighters, armed with 4 30mm cannons that can shred bombers in seconds, the Me-262 represents a potential solution to the bomber problem that has plagued Germany throughout 1943. He begins pushing for immediate mass production, for diverting resources from other aircraft programs, for prioritising the Me-262 over everything else in the Luftwaffe's inventory. The confrontation comes in May 1944 at Hitler's headquarters in Berchtesgaden, during a conference on aircraft production attended by Göring, Field Marshal Erhard Milch, and other senior Luftwaffe officers. When discussion turns to the Me-262, Hitler asks how many of the aircraft already manufactured can carry bombs. Milch, unaware of the political minefield he's walking into, replies honestly that none have been modified for bombing, that the Me-262 is being manufactured exclusively as a fighter. The silence that follows is described by witnesses as terrible. Hitler's face flushes red as he realises that his December comments at Insterburg were ignored, that the Luftwaffe has spent 6 months building fighters when he expected bombers. The explosion of rage that follows becomes legendary among those present. Hitler denounces Milch, Göring, and the entire Luftwaffe leadership as unreliable, disobedient, and unfaithful to the Reich. He accuses them of sabotaging his vision, of deliberately undermining his authority, of caring more about their own ideas than about Germany's survival. The tirade continues for what witnesses describe as an eternity, Hitler's voice rising to a shriek as he details exactly how the invasion will unfold, how Allied troops will consolidate their positions because Germany lacks the fast bombers to disrupt the landings, how the war will be lost because his orders were ignored. When the storm finally passes, Goering summons the key officers to deliver Hitler's formal orders. The Me-262 program will be converted immediately to bomber production. Every aircraft in manufacturing will be modified to carry bombs. Fighter production is cancelled. Training of fighter pilots on the Me-262 stops immediately, replaced by bomber pilot conversion courses. And most significantly, nobody in the German military is permitted to refer to the Me-262 as a fighter, or even as a fighter bomber. The official designation becomes Blitzbomber, fast bomber, and any deviation from this terminology will be considered insubordination. Messerschmitt and Galland attempt to argue, pointing out that the aircraft's design makes it far more effective as a fighter than as a bomber, that the modifications required will delay production, that Germany needs interceptors desperately. But Göring cuts them off, explaining that further debate is impossible, that Hitler's decision is final. The reader should understand that at this exact moment in May 1944, the WW 004 engine is still not ready for mass production. The engines being fitted to prototype and pre-production Me-262s are having service lives measured in hours, sometimes less than 10 hours, before catastrophic failure. The production version, the WW 004B, is undergoing final development, with engineers still solving vibration problems, still refining fuel control systems, still searching for material solutions to the temperature challenges in the turbine section. No Me-262s are ready for combat deployment in any role, fighter or bomber, because the engines simply cannot survive operational use. The bomber conversion order doesn't delay the Me-262's combat debut significantly, because nothing can enter combat until the engines work reliably. What the order does accomplish is diverting engineering effort toward bomber modifications when that effort could be spent solving the aircraft's operational problems. It confuses production planning, forces the training establishment to abandon fighter pilot conversion and start training bomber crews instead. And, most damagingly, it demoralizes the fighter pilots and commanders who understand that the Me-262 represents their only hope against the Allied bomber offensive. 2 weeks after the Berchtesgaden meeting, on June 6, 1944, Allied forces storm ashore at Normandy. The invasion that Hitler feared, the landing he wanted Me-262 bombers to disrupt, happens before a single jet bomber is operational. The opportunity to use fast bombers against invasion beaches, if it ever existed, passes, while German engineers struggle to make jet engines that won't destroy themselves after 20 hours of operation. By August 1944, the WW 004B enters production, with an average engine life extended to 25 hours. This remains an absurdly short operational life, compared to piston engines that routinely operate for hundreds of hours between overhauls, but it represents enough reliability that mass production can finally begin. The 25-hour life limit means that Me-262s require new engines after roughly 10 to 15 combat sorties, depending on flight duration. This voracious consumption of engines places enormous strain on manufacturing. Each Me-262 needs 2 engines, and those engines must be replaced every few weeks, meaning the Luftwaffe requires a steady stream of thousands of engines monthly just to keep existing aircraft flying. The manufacturing challenges become nightmarish as Allied bombing intensifies throughout 1944. The main Junkers plant at Dessau is heavily bombed in late 1943, forcing production to disperse to smaller facilities at Koten and Muldenstein that lack the specialized equipment needed for precision jet engine manufacturing. Supply lines for critical materials break down as the Allied advance captures territories that provided resources Germany needs. Nickel, essential for high-temperature components, becomes almost impossible to obtain after Finland, Germany's primary nickel source, exits the war. Engineers develop substitute alloys using manganese, chromium and other available elements, but these materials don't perform as well at extreme temperatures, further reducing engine reliability and service life. The manufacturing process for hollow turbine blades, already complex, becomes even more difficult as experienced workers are drafted into the military and replaced with forced labourers who lack the training and often the motivation to produce components to the necessary precision. Adolf Galland, watching this disaster unfold, writes in his memoirs about the frustration of having the world's best fighter sitting in production while being misused as a mediocre bomber. The Me-262 carrying bombs loses much of its speed advantage. The bomb racks create additional drag, and the aircraft's high-speed, low-altitude bombing attacks prove far less effective than conventional bombing by purpose-built aircraft. Worse, training bomber pilots to fly the jet consumes time and fuel that Germany can barely spare, as these pilots must learn completely new techniques for handling an aircraft that responds unlike anything they've flown before. The Me-262's high landing speed, over 120 miles per hour, catches out pilots trained on conventional bombers. The engine's sensitivity to throttle changes, requiring slow, careful power adjustments to avoid flameouts, proves difficult for pilots accustomed to piston engines that tolerate rapid throttle movements. And the swept wing design, necessary to maintain proper centre of gravity with the engine weight, creates stall characteristics that differ from conventional aircraft, leading to landing accidents that destroy aircraft and kill pilots. Hitler, watching the Allied advance accelerate after Operation Cobra breaks German lines in Normandy, finally recognises that fast bombers cannot stop Patton's tanks racing across France. In September 1944, he rescinds the order converting all Me-262 production to bombers, permitting fighter production to resume. But 4 months have been lost. 4 months during which Germany's aircraft factories, already hammered by Allied bombing, have struggled to build bombers instead of the fighters the Luftwaffe desperately needs. More than 100 completed fighter airframes sit in storage awaiting engines, while bomber variants roll off production lines. The training establishment must pivot again, converting back to fighter pilot training after months focused on bomber operations, wasting time retraining pilots in tactics they should have been learning all along. The Me-262 finally enters combat in meaningful numbers in early 1945, far too late to affect the war's outcome. Jagdgeschwader 7 forms as the first dedicated jet fighter wing, equipped with Me-262s whose pilots have barely enough training to take off and land, much less engage in complex combat against experienced Allied aviators, flying inferior but far more reliable aircraft. The new jet pilots face challenges their training hasn't prepared them for. The Me-262's speed advantage proves less useful in combat than expected, because the aircraft's 30mm cannons have limited range, forcing pilots to close within 600 meters of their targets. At the speeds the Me-262 flies, that range closes in seconds, giving pilots perhaps 2 seconds of firing time before they must break away to avoid collision. The jet's high speed also makes it nearly impossible to dogfight with conventional aircraft. Trying to turn with slower fighters bleeds off the Me-262's speed advantage, putting it into a realm where piston fighters can outturn and outclimb the jet. Experienced Me-262 pilots develop tactics exploiting their speed, making slashing attacks through bomber formations before Allied escorts can react, then diving away at full throttle to escape pursuit. These tactics proved devastatingly effective when executed properly. On March 18, 1945, 37 Me-262s intercept a massive American raid consisting of over 1,200 bombers and 600 escorts, shooting down 12 bombers and 1 fighter, while losing only 3 jets. This kind of exchange ratio, if sustained, could theoretically make the Allied bombing campaign unsustainable. But the Me-262 force never grows large enough, never achieves the reliability necessary, never receives the fuel supplies required to maintain sustained operations. The engines remain the critical weakness throughout the Me-262's service life. Pilots describe the terror of hearing engine spooling sounds change during combat, knowing that a flameout at low altitude means almost certain death. The engines are sensitive to debris from exploding enemy aircraft, sometimes ingesting fragments that destroy compressor blades and cause immediate failure. Mechanics work around the clock replacing engines, sometimes changing both engines on an aircraft between morning and afternoon sorties, struggling to keep enough jets operational to make a difference. The standardized 25-hour engine life means that units flying intensive operations burn through engines faster than the disrupted manufacturing system can replace them. Allied pilots, learning to exploit the Me-262's weaknesses, develop tactics for attacking the jet during their most vulnerable moments. The Me-262 requires high speeds for takeoff and landing, making it predictable during these phases. Allied fighters begin patrolling known Me-262 bases, waiting for the jets to land when they're slow, low on fuel, with engines that cannot tolerate the throttle changes needed for violent evasive maneuvers. German attempts to protect their jet bases with conventional fighters and intensive anti-aircraft defences achieve limited success, but the Allied numerical superiority is overwhelming. For every Me-262 that takes off, dozens of American and British fighters prowl the sky, waiting for opportunities. The fuel crisis becomes catastrophic by early 1945, as Allied bombers destroy synthetic fuel plants and advancing armies capture remaining oil sources. Germany produces more Me-262s than it can fly, with dozens of jets sitting idle on airfields because there's no fuel for training flights, no fuel for combat operations, barely enough fuel to ferry aircraft from factories to operational units. Pilot training, already abbreviated due to time pressures, becomes almost non-existent as instructors lack fuel for the repeated practice flights necessary to master the jet's unique handling characteristics. The numbers tell the story of opportunity lost. Germany manufactures approximately 1,400 Me-262s during the war, but only about 300 ever see combat. Most sit in factories or at airfields awaiting engines that never arrive, or waiting for fuel that doesn't exist, or lacking pilots trained to fly them. At any given moment during early 1945, the Luftwaffe can typically put only 20 to 40 Me-262s into the air, a force so small it cannot influence battles involving thousands of Allied aircraft. German pilots flying the Me-262 achieve remarkable success rates when they can fly, claiming over 500 Allied aircraft destroyed for the loss of about 100 Me-262s in combat. But these numbers must be understood in context. The jets typically attack bomber formations, large, slow targets that are relatively easy to hit compared to nimble fighters, and the Me-262 losses don't include the dozens of aircraft destroyed on the ground by strafing attacks, the jets that crash during landing accidents caused by inadequate training, or the aircraft abandoned when advancing Allied armies overrun their bases. Adolf Galland, relieved of command after prolonged disputes with Hitler and Göring over fighter tactics and Me-262 deployment, forms Jagdverband 44 in March 1945, a small unit composed of Germany's top surviving aces flying Me-262s. This elite formation, never numbering more than squadron strength, achieves impressive success during its brief existence, demonstrating what the jet might have accomplished if deployed earlier, in larger numbers with adequate support. But even Galland's experts cannot overcome the fundamental problems of engine reliability, fuel shortages, and overwhelming Allied numerical superiority. The unit's operations are sporadic, limited by engine availability and fuel supplies, and ultimately, they can only slow the inevitable rather than change it. The question that haunts historians examining the Me-262 program is whether earlier deployment could have changed the war's outcome. The answer requires understanding multiple factors that all worked against Germany. Engine development could not be rushed beyond certain limits. The Jumo 004's fundamental design challenges, the material shortages, the manufacturing precision required, all imposed timelines that no amount of priority could compress indefinitely. Even if Hitler had never interfered with the bomber conversion, even if production had focused exclusively on fighters from the beginning, the Me-262 could not have entered service significantly earlier, because the engines weren't ready. The bomber diversion probably delayed fighter deployment by several weeks to perhaps 3 months, significant but not decisive given the other problems. The strategic situation by late 1944 was such that even hundreds of Me-262s could not have prevented Germany's defeat. The Luftwaffe lacked the fuel to fly them, lacked the experienced pilots to man them after years of attrition had killed most veteran aviators, lacked the infrastructure to maintain them as Allied bombing reduced factories and railways to rubble. The Me-262 was a remarkable technical achievement, a glimpse of aviation's future, but it arrived when Germany's defeat was already certain, when the question was not whether the Reich would fall, but only when. The legacy of the Me-262 extends far beyond its limited wartime service. Allied forces captured dozens of Me-262s as German resistance collapses, shipping them to Britain, America, France, and the Soviet Union for detailed study. American, British, and Soviet engineers carefully examine every aspect of the German jet, learning from both its successes and its failures. The swept-wing design influences post-war fighters from the F-86 Sabre to the MiG-15, both using similar wing geometries to manage transonic airflow. The lessons learned about jet engine reliability, about the challenges of high-temperature materials and precision manufacturing, inform the development of improved turbojets that power the first generation of Cold War combat aircraft. The Lockheed P-80, America's first operational jet fighter, benefits directly from Me-262 technology, shared by German engineers brought to the United States after the war. The Soviet Union's jet program, rapidly advancing in the late 1940s, draws heavily on captured German research and on German engineers who continue their work under Soviet direction. Even the swept wing of the Boeing 707 airliner, the aircraft that revolutionizes commercial aviation in the 1950s, traces its lineage back to German research conducted for the Me-262. Anselm France, the Junkers engineer who led UMO 004 development, emigrates to America after the war, where he works for Lycoming, developing turboshaft engines that power helicopters throughout the Cold War. His experience with the Me-262's troubled engines informs his subsequent work, demonstrating how failures can teach as much as successes when engineers learn the right lessons. The Me-262 represents one of history's great what-if scenarios, a weapon system that arrived too late primarily because its crucial component, the UMO 004 engine, could not overcome fundamental engineering challenges within the compressed timeline that Germany's deteriorating strategic position demanded. The political interference, the strategic confusion, the resource shortages all contributed to the delay, but the engine remained the critical path throughout. Germany needed an engine that could survive 100 hours between overhauls and got one that barely lasted 25 hours. They needed engines that could tolerate combat maneuvering and throttle variations, and got engines so sensitive that pilots had to nurse them constantly. They needed manufacturing processes that could produce thousands of reliable engines monthly, and got a system that struggled to deliver hundreds of problematic units. The story of the Me-262 is ultimately about ambition exceeding capability, about reaching for revolutionary technology before the fundamental problems are solved, about the cruel reality that wars are won not by wonder weapons, but by reliable, producible systems that can be manufactured in sufficient numbers to actually affect the battlefield. The jet engine that could have changed the war arrived too late, because it was too advanced for the time, too demanding of precision manufacturing and rare materials, too complex to perfect under wartime pressures. The Me-262 flew, it fought, it demonstrated the future of air combat, but it could not save Germany, because the engines that made it possible were themselves a miracle that Germany's collapsing industrial base could not sustain. In the end, the first jet fighter in operational service remains a testament to engineering brilliance hampered by insurmountable practical challenges. A revolutionary aircraft crippled by an engine that promised transformation, but delivered only tantalizing glimpses of what might have been. If development had started earlier, if resources had been more plentiful, if the fundamental problems of high-temperature materials and precision manufacturing had been solved before the desperate final years, when every delay meant the difference between a potential war winner and an interesting footnote to history.